Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 16. Today's topic is floating point numbers, or floaters as I like to call them. Now, real talk, I don't always drop a floater, but when I do, you know it's going to be an upper decker. I mean, it's just more considerate that way. It doesn't get all mashed up in the intake valve, plunger, assembly. I don't know how toilets work. It might as well be magic to me. Also, I don't really call them floaters. I mean, that'd be kind of weird, wouldn't it? Anyways, all this talk of floaters makes me yearn for the halcyon days of the poo game. Yes, we're back to the motherfucking poo game. What can I say? I'm a scat man. Skibbidi-bidi-ba-ba-dum-bo. Okay, I'll stop that now. Anyways, now the problem with the poo game, you know, aside from it just being generally a shitty game, is that all the stuff in the game, like the dude and the poos, it's all moving at the same speed, right? And I mean, that's not cool. Now, we could make the things move faster, right? Right now, everything moves at 1 pixel per frame, either in the X and or the Y direction. We could make it move like 2 pixels per frame or 3 pixels per frame. But what if we wanted to make it move slower? What if we wanted to make it move at half a pixel per frame? Well, you can't do that. You're fucked, basically, because our velocity is stored in integers, and integers can only store whole numbers, you know, integers. So it's going to be 0 velocity, or 1, or 2, or -2, but it can't be 0.5. No, too bad, you're fucked. So we want finer grained control over our, you know, physical properties like velocity, and in order to get that, we're going to use floats, because that's what floats are. They're basically like, you know, decimal numbers, so they can be 2.5, 0.125, whatever the fuck you want. I mean, there's limits obviously, but you're not limited to only whole numbers is what I'm trying to say here. So let's do this shit. Alright, so like I said in the last tutorial, the Git tutorial, from now on I'm going to be distributing the code via GitHub. So here is the repo for the poo game now. It's got its own repo, and the link will be, you know, on the wiki page as usual. You can clone this, and then we go into, click on this button, we go into Team Explorer, Manage Connections, and we're going to clone. I'll select my my local folder for the repo, and we'll paste in the Git URL, and we'll clone that fucker. Now, if you're going to follow along at home, or you're going to attempt to do this after you've watched the video, what you should do is, you know, go click on the home button in Team Explorer, and then you want to go to maybe not branches, you want to go to changes, view history, and where you see T16 start, right click here, create a new branch, maybe name it something like T16 dev, click the create branch, and then you will now be in the T16 dev branch, view history, and here is where you're going to start working off of. So you don't want to contaminate the master branch. Create your own, work in that. I forgot to do that in my video here, but it's alright. After we've cloned, we go home, we open up the solution, and Bob's your uncle. There we go, we got all our stuff here from the poo game. Now, this is mostly the same as what we had at the end of tutorial 14, or 13 actually, tutorial 13. But I did add some minor upgrade of the framework code, and I added sound to the game. And you can see the commit history for details of that. For more info on how to use the sound pack, the Chili sound pack, you can see my video on that, and the link will be on the wiki page. But we won't be focusing on it. I just added sound because why the fuck not? So, what we want is we want the velocity. Let's go to poo. We want the velocity of shit to be numbers like, you know, 1.5, 0.7, etc. So let's do a little test here. Let's make the VX and VY member variables floats, just like this. And then the input for the initializer will also have to be float, like this. And then we're going to have to change the function here. So we'll toggle that. And these guys will be float like so. And this can all stay the same. I mean, a lot of the operations for int, they work the same for floats. So assignment works the same. Most of your mathematical operations, multiplication, division, those operators all do what you would expect them to do when you use them with floats instead of ints. So now we've got these guys. They take floats. Let's go to where they are being initialized. And that's here in the game constructor and game.cpp. And what we're going to do is we're just going to initialize them to 0.5 to start off with. So 0.5, and here's the thing with floats. You put an F.
900.
An F.
Sorry, Don. Come on, big money.
So you put 0 point something and you put an F at the end. And that specifies that it's a float. If you don't put the F, that means it's a double, which is a value that takes up twice as much memory as a float and is also slower to process. So we won't be using doubles, we'll be using floats. So anytime you're using something with a decimal, put an F after that and you're all good to go. So we're going to make our poos, they're all going to be moving, down and right by 0.5 pixels per frame. And if we build that, it should build. You see, we get a couple warnings here, but we'll talk about that in a jiffy. First off, let's just run this and see if it works. Hint, it's not going to work. And let's press enter, and our poo is now stationary. Well, what the fuck? What's going on, dog? So what do we do when things don't work the way we expect them to? Well, we set that mother to debug, and we drop down a breakpoint somewhere. Now, where are we going to drop our breakpoint? Well, we want to do it when we're updating the poo, basically. So where is that? That's right here on this line. So we're going to drop a breakpoint here, and we're going to start our engines. Press enter. So here we are. We've just broken at the update. We don't have our windows, so let's open up the autos window anyways. And let's step into poo update. So this is updating probably the 0th poo. We'll just step in here. This. Okay. So this is the current poo that we're working on. The current poo has a velocity x and y of 0.5. So that is so far so good. We know that the velocities are fine. Now, we're going to add the velocity 0.5 to the x position 458. And what happens when we do that? Nothing happens. Nothing at all. So what the fuck? What gives? Well, there's some things you got to be aware of when you start mixing operations between integer types and floating point types. All right, so let's say the computer is trying to perform the operation, 458 plus 0.5. Now this one is an integer, int. This one is a float. Now ints and floats have very different representations and very different ways of being calculated inside the CPU. So you can't, you don't have an actual CPU operation that works with one int and one float. So in order to perform this calculation, there has to be a conversion. And the C compiler will do what's called a promotion. It will promote this integer into a floating point value. And then the operation is going to be performed between these two floating point values. And the result is going to be 458.5. And so you might be saying, okay, that's great, but then why is it not happening that way in the computer? Well, so what's happening is we're assigning this floating point number to this integer x, and that means that we're going to be we're going to retrieve the integer value from x, we're going to add 0.5 to that, which means we're going to convert that retrieved integer to a float. We're going to do the floating point addition. But now we've got to assign this floating point number to an integer. Integers can't store floating point numbers, they're completely different. So now you convert back to integer, and then you assign that converted value to the variable x. Now the thing about conversion from floating point to integer is all it does is it chops off the decimal part. It just takes the part after the decimal point. And that means you're going to lose that 0.5 that you just added, and it's going to remain 458. And then the next frame, same thing's going to happen, and you're never going to go anywhere. And that's why our poos are stationary. So what we need to do is we need to make x and y also floats so that they can hold on to and remember that fractional part between frames. so it doesn't get lost. So we make the member variables x and y float. We make these parameters to init float. And then we also have to make them float in here. And if we build that, we should get a whole shit ton of warnings, but there shouldn't be any errors. We should succeed. And I'll talk about these warnings in a second. They are not important. They are important, is what I'm trying to say. Anyways, so now let's run this fucker. Let's run in debug. And if we go, oh, I didn't want to do that. Let's remove that breakpoint. And now our poos are, moving at a slow crawl of 0.5 pixels per frame, which is what we expect. So now we are free to set any kind of velocity that we want for our poos. All right, let's take a look at these warnings now. What are they saying? What's this compiler's dysfunction here? So if we double click on one of these, it'll take us to where it thinks there's a problem. And it says here, conversion from int to float, possible loss of data. Now, this X distribution and Y distribution, these are integer distributions. So they're returning integers, but the init function here is expecting a float. So what the compiler will do is it'll say, well, you need a float. You've got an int. I'm going to convert this int to a float for you. But here's the thing. Converting from float to int, like I said just recently, when you convert from a float to an int, you lose the fractional part. You lose the part after the decimal point. So you lose data whenever converting from float to int. And it says right here, possible loss of data. Now, the same thing is for integer in different situations. I won't go into the details, but you can also lose some data when you convert from int to a float. Although for our case, it probably won't happen. So what the compiler does is it says, okay, I'm going to do this for you, but are you sure this is what you want to happen? Did you mean that? Are you sure you didn't mean to pass in a float? And that's what the warning is about. So what we want to do is we want to tell the compiler, yes, we want you to convert this. We want to make it clear. And the way we do it is with casting. All right, let's take a look at one of these other warnings here. So let's look at this one. We got problems here. We got int, but we got float here and we got int here. So we're mixing our ints and our floats. Conversions are happening and the compiler is saying, do you really want to do this? So what we're going to do is, first of all, width and height are only going to be used now for these calculations here. And these calculations are going to be done in floating point. So let's make our width and our height also floating point, like this. And that way we don't have to do conversions back and forth. Conversions aren't free. They aren't super expensive, but they aren't free. And so, I mean, if you don't need to do conversions, why not just not do them? So now this is in float. This is in float. So this one should also be float, right? And now all these calculations are with float. Now this guy, screen width, is integer. And I'm going to leave it integer because it's a very integer thing. Pixels, you can't have half a pixel, right? So this is going to stay, screen width is going to stay int, but it's going to have to be compared with a float. So you're going to have to convert it to float. So we're going to tell the compiler, convert this to a float. And all you do is you type the name float and then you type brackets around the thing you want to convert. That's one way. The other way is you can type brackets, not brackets, parentheses. You can type parentheses around the type name and put it before the thing you want to convert. And this is also a way of conversion, but I like the function style better. So I'm going to do it like this. And the same for here, graphics screen width. We can actually perform the conversion after we subtract 1 from the screen width. So we do this calculation in integers, then we convert to float, and then we process with this float here. And the same for down here, we need to make this a float. And we need to make these guys float as well. Float your motherfucking boat. Now, if we try to build this, we still get a butt ton of warnings, but the warnings for that code section for poo update have now disappeared. So everything in poo update is now being explicitly converted the way we want. We're telling the compiler exactly what to do, and the compiler is saying, okay, man, you know what you're doing. Now, we still got other things to fix. So, test collision here. We're testing between dude and poo, right? Now poo is floats, but dude is still an integer space. We're going to want to bring the dude into floats as well because, we also want the dude's velocity to be more flexible. So in do.a, which make all these ints into floats like this. And don't forget to put the 0.0f at the end of every number now because we've got to specify these literals as floating point literals. If you leave them as just like this, the compiler is again going to give you a warning because you're trying to convert from an integer into a float. So specify your literal constants as floating point to begin with, and you won't get any errors or warnings. So now in do.cpp, we got to make all these guys floats. Then we go all the way up here, and we are going to get warnings in here now because of, the same thing. We've got to make everything float. So make this one float and convert these to floats. Same down here. Like this, everything's now float in the dude. So let's try to build again, make sure we haven't introduced any errors into our code. So far so good. Still a shit ton of warnings, but that's fine. All right, let's see what else warnings we got here. So test collision. All right, so dude get x, that's a float. Get width, that's a float. This has also got to be a float. So let's make these guys floats, and we'll build again. All right. Well, that actually got rid of a lot of... Oh, wait. Never mind, that was because we rebuilt, so some things didn't get built again. Alright, so what do you not like about this? Poo right float is equal to dimension is an int. So again, we're gonna have to go into goal. This is the way of the world, basically. Once you start making things float, you're gonna be making, maybe a lot of things float. But that's fine. From now on, we're going to be starting with float when necessary, so you won't have to do this all the time. But you're going to have to do it some of the time. Alright, so make some more things float. Let's build. We're gonna work our way through the warnings and get rid of them all. Alright, initializing conversion from int to float, possible loss of data. So you want floats here. Float. And float. What else? Respawn is probably also going to want floats. So let's just go into there and float it up. Fuck. There we go. And build that mother again. Let's see where it goes wrong. Alright. Draw rect. Now, here is where, again, here we can't change anything now to float. It's already float. We got x and y float, but draw rect takes integers. We're not going to change the drawRect function to take floats because it makes no goddamn sense. What does half a pixel mean? So we're going to convert this now to integer when we call our drawRect function. Conversion to integer for the final draw out to the screen. And we're getting fewer and fewer warnings. All right, what are you pissing about here? So the thing is pointing here, and that probably means it's in this initializer list somewhere. Conversion from int to float, possible loss of data. Right. So the goals, this X distribution is a uniform int distribution, and it's trying to use that to initialize something. Meter is fine. Meter is all ints. So first off, this one here. So our X distribution, Y distribution, this has now, we don't want a uniform int distribution. We want a uniform real distribution.
First things first, I'm the realist. First things first, I'm Bruce Willis. First things first, I'm Bear Grylls. First things first, I'm the Skrillex.
And that'll give us a distribution that also has fractional parts. And we want it not to output ints, but to output floats. So we've got to put float inside of these angle brackets in here. And if we do that, now this will be outputting floats. Let's build it again. And now we have no warnings, but that is deceptive because remember, when you build, it will not rebuild things that haven't changed. So we still have warnings in there, believe me. If we rebuild solution, we're going to get a shit ton of warnings. Don't worry. Don't worry, we got like hundreds of lines of warnings there. But most of them are going to be very simple to fix. So let's go after the low-hanging fruit now, which is, if we go into, let's look at poo.cpp. So in the draw function here, we're drawing x plus 14 to put pixel. Put pixel takes an int, x is a float, so there's a bad touch going on here. Now what we could do is we could go into here and we could convert each and every one of these to int. So put int conversion here for every single line. That sounds like a fucking terrible idea.
I got bronchitis.
So what we're going to do instead is we're going to create a conversion to integer of x and y. So we're going to go constant int, or we'll call it x int is equal to int x, and constant int y int is equal to int y. So here we'll create the conversion versions, and we'll try to spell const correctly here. And in here, we're just going to replace x and y with x int and y int. All right. So we'll do Control F, find and replace x with, oh fuck. So here we are gonna, if we just do x, we're gonna hit these guys too, and that's not good. So let's try x, comma, right, because that'll only hit these guys. And then we're gonna replace that with x underscore int, and we'll replace all. Beautiful. Not beautiful. Sorry, not sorry, because we forgot to put the, we're matching the x and the comma, so we've got to replace with x and comma. All right, try again. Replace all. Much better. All right, now we're going to do the same for the y, like this, and there we go. We have now rid ourselves of a shit ton of warnings, but we've got one more of those in the form of the motherfucking, where is it? The dude, right? The dude also has the same ailment in his draw function, so I'm going to do the same in here. And if we do that, it should look something like this. And now if we build and rebuild solution, we should see a lot fewer warnings. All right, that seems a little more digestible, if you ask me. So let's go and squash the remainders. All right, so we got lots of ints here. We'll make them floats. Like so. And what else do we got? This one's still in here. This one's this one. Oh, is this the last place where we have problems? Let's rebuild again. And there we go. We've got clean compiler output, no warnings. And that's what we like. You always should strive for builds that have no warnings in them. And you might say, well, that was a fuck ton of work, Chili. And I mean, it still works. Why do you even care about those warnings? And the thing about warnings is, they're warnings for a reason, because they often indicate things that can be wrong. So if you leave a bunch of warnings in there that are okay, that are things you're okay with, they will drown out the actual warnings that you need to be keeping an eye out for. So keep your build clean, remove all those warnings. If you have implicit conversions, make them explicit, or make the types match, get those warnings out of there, so that if you do get a warning for something, important, for something critical, you'll actually see it and be able to respond. All right, now let's go back to game.cpp, and we just put some test values in here for the velocity. Let's give it some real velocity values. So we want a uniform real distribution. So we'll make that one real, and we're going to make it output floats. And so what is the distribution we want? Well, let's say we want a distribution of, I don't know. So the speed will be from -3, and we'll do negative 2.5 to positive 2.5. Shit. 5, and put F's in there, because fuck. And then we are going to use this velocity distribution in here, like so. And if we build all that stuff again, just to be sure, and then we run it, and now we got our poos. Some of them are zinging around, some of them are, whoa, shit, some of them are just kind of putting around, but yeah, we got lots of different kinds of motion here, more angles, not just 45-degree angles or 90-degree angles on the movement, and I like it. It's a definite improvement on what we had before. And I think this would be a good time to commit our changes to the repo. Now, I've been a bad boy. Chili's been a bad boy. I didn't create a working branch before I started, but I'm gonna in post I'm gonna add a note to you guys to create a branch when you're following along. But anyways, so we're working in the master branch, which is not good. But let's commit our change anyways. So here's all of our changes that we've added. We'll add a message in here. So something simple here. Overhauled game entities to use floats for their physical properties. There you go. And you commit all. And now that is a part of the history of commits for here. So here's our master. You guys will probably have your master here, and then you'll have your working branch that you created here. But anyways, that's neither here nor there. So that's floats. Positions, physical stuff, that's often going to be float. Later on, graphic stuff, like for example the vertices of triangles, will also be represented by float. Floats are going to give you more freedom and flexibility in the games you make, and that's why I'm introducing them right now, give you a little more to work with. But there's one thing that I want you to note. I would recommend you prefer ints or integer types over floats when you don't need to represent fractional types. Don't make a simple counter variable or a variable that remembers the number of poos. Don't make that a float. That's dumb. And there are a bunch of reasons for it. One is it communicates your intention, and the other is floats can have errors from rounding or the way that they're calculated. They can be slightly off, especially you have to be careful of or avoid comparing two floats for equality. Because even if they're a little bit off of one another, you're going to get unexpected results. They have to be exactly the same, and that's hard to do with floats and floating point calculations. Now, at the same time, the next time you get a bug, don't just assume, it's that Chili talked about this, it's the floating point thing, they're coming for me now. No. Occam's razor applies. The simplest explanation is probably correct, and the simplest explanation is that you fucked up something dumb. No offense or anything, but that's probably what it is. It's never lupus, and it's never going to be floating point error, except when it is. And this is a thing not only in C++. Floats are the same, basically, any programming language. Most machines, they're representing them the same way, and it's imperfect. They're inherently not a perfect way to represent numbers, but they do the job well. So again, don't jump to the conclusion. Don't become paranoid. The floating point numbers are out to get me. No. But just keep it in the back of your mind somewhere. It's probably not going to be an issue for us, but I just want you to know that it is a thing that exists. All right, now it's time for the homework. I've got an interesting little challenge for you guys here. A little bit of math, nothing too crazy, but it's going to be a bit of a puzzle. What I want you to do is create a function in graphics, just like we created draw rectangle. Now I want you to create draw circle. And it's going to look something like this. I'll let you figure out the details for yourself. But when you run it, so here you go. And you've got a circle being drawn here, and it obscures things because I'm drawing it at the very last. And yeah, that's it. Make a function to draw a circle. That's all you need to do. Easier said than done, right? Well, we'll see. Now, there are two hints I'm going to give you. I'm going to make this mostly just up to you guys. And of course, I'll show you how to do it and how it works in the solution video. But two big hints. One is, even though I showed you floating point in this video, you don't need to use floating point to draw the circle. And the way I'm doing it, I'm not using floating point. So, no need to use floating point. You might say, well, then why are you using this for this? Why is this the homework solution? It's math, right? It kind of relates. So, and it's interesting. So, one hint, don't need floating point. Another hint, I'm just going to put this image up here on post, and that's all I'm going to say about that. But yeah, so good luck drawing circle, and you'll see the solution either way if you watch the solution video. But anyways, this has been floating point numbers. They're going to be useful. We're going to be using them a ton. Hope you enjoyed them. If you did enjoy the video, click the like button. It helps a lot. Next video, we're going to be looking into measuring time. so that our game speed is going to be independent of frame rate. Until then, see you soon with some more C++.